Hooray! I think we're live. So, hello. Welcome to my live stream with Lewis, Jay, and me, my friends. I cannot wait to answer your questions. Hooray! Maybe not my best song ever,
Love
but
those songs.
but it's
Yay.
done. Yeah. So everybody, welcome to. We got to come up with a name for this live stream because it's definitely not the StatQuest live stream. This is like the Louis Serrano, Josh Starmer, and today Jay Alammar live stream Q&A awesomeness. So I'm really excited about this. I've got two of my biggest heroes here with me today, and I cannot wait to hear what they have to say. We've got some great questions coming up. We're going to be talking about transformers. We're going to be talking about career paths, the big stuff, and we're also going to be talking about other things. And one of those things is Lewis, can you ask the question? I forgot who it is that asked this
Yeah,
question.
definitely. So first of all, I'm very happy to be here with you guys. You are two of my AI heroes and two of my favorite people. So I'm very happy to be here. We have a great crowd. The first question for people, I just want to say for anybody joining us, like, where are you joining us from?
Oh
So
yes,
I'll start. I'm joining from Canada. I'm originally from Colombia. I'm very excited about the soccer coming up. But I'm in Toronto, Canada,
uh-huh.
and you are, and yeah, you're in North Carolina, I believe, and
I'm
Jason
in
from
North
Toronto.
Carolina. Jay, where are you right
Yeah,
now?
So
Jay's also in
I'm
Toronto.
originally from Riyadh, Saudi Arabia. As part of my role, I travel a lot. I speak at developer conferences. At the moment, I'm at Cohere's headquarters in Toronto. So that's where the company is sort of based. So I spend some time here as well. Toronto.
Fantastic.
Yeah, great. So Jay and I hang out in Toronto, and you're
Very
more than
cool.
invited, Josh, to come
I
come
know.
join us.
I can't wait to come up. I'm gonna visit. Just you wait. It'll
Yeah.
be the coldest day of the year. That's when I'm gonna come.
Okay. Sure. It's easy to pick. Yeah, you have a lot of days to pick.
Yeah.
All right, well,
Uh,
let me just start. Let me just feed a question that came on the live. And by the way, anybody here? Oh, I see they're joining us from Bolivia, Australia, India, Saudi Arabia, like
Very
Melbourne.
nice.
Um,
What time is it in Australia right now?
oh, it's probably like
Possibly like
the same
midnight.
thing backwards, like 11 p.m. or something.
Yeah, so
Sorry, or
this
maybe
is
we're
like
the
this is
backwards
like
one.
late night TV.
Exactly, we're on late night.
It's awesome.
Yeah. So, by the way, for people in the live, yeah, we have some questions that people asked before, so we're gonna answer those. But by all means, ask any questions in here. I see someone from Colombia. Hi, Susanna, from Montreal, from Cyprus. I'm gonna ask one question, and it's for the three of us
Uh-huh.
that Mohammed asked, and it said, so start with Josh. For who is the target audience, and what are the reasons for you choosing a theatrical and dramatic constant style? So basically, you have a really cool, funny
Yeah.
style with a lot of running gags and stuff like
Yeah.
that. How did that start, or
Yeah, where did it all come
uh,
from? So
yeah,
this channel, I originally the original idea for the channel was to directly teach my coworkers. Uh, what's going on over there, Lewis?
oh sorry, I just
Just
gotta
just
plug my headphones.
rearranging the furniture.
Yeah, exactly.
Anyways, so I started off trying to teach my coworkers. I used to work in a genetics lab at the University of North Carolina at Chapel Hill, and the idea was um, they needed to learn statistics, and so I started making these little PowerPoint presentations, and I had a little Friday morning chat where I try to teach the genetics researchers statistics. And so if you watch any of my early videos, every example is given in the language of genetics and mouse genetics in particular, because the people I worked with did mouse genetics. And so I was directly trying to talk to them very specifically. I had in my mind that there would be like a virtual bookshelf in the lab itself. I guess it's virtual, so it wouldn't really be there. But the idea was whenever these people, my audience of 6 other people, needed to know something, they could just click on the link and they would learn about it, and it would be in the language that they understood. So it just so happened that other people started watching these videos, and it was non-mouse geneticists. And so then I started trying to like generalize my examples and make them a little more approachable from different angles, something everyone could relate to. I talk about M&Ms, candies, and things like that. Everybody likes candy, I think, to a certain degree, or most people. And so I tried to broaden it. But the idea is it's for, I'm still in my mind, I'm still trying to teach these geneticists who aren't very good at math, but are very smart people. So if I can explain everything in a step by step way, they can follow it, and they're smart enough that they can figure it out. And I've just kept that as my sort of ideal audience, is someone who is smart, but maybe coming from a background that isn't mathematics and isn't genetics, or maybe it is genetics, or maybe it isn't statistics, maybe it isn't ML, maybe it isn't AI. But they're smart people, and so if you go through things slow enough and one step at a time, they'll get it. So that's my intended audience, and that really has driven. Someone also they also wanted to know what my style, why I settled on my style. That's also been driving my style, which is the original audience was trying to teach statistics to people who hated statistics. So I came up with things like BAM and double BAM, and I came up with little characters, Squatch and Norm, to kind of like make it a little bit more interesting and a little bit more exciting than maybe statistics actually is. I personally feel very excited about it, but I know a lot of other people are not. So I try to inject things to just kind of pump people up, and that I think hopefully explains the style of StatQuest. Yeah, Lewis, Jay, do you have anything to say about your? I know you guys do things differently.
Yeah,
Is there
we,
a
we
story
actually
there?
have we actually had a similar start because Jay and I worked at Udacity together. We worked at different places. We worked at Cohere, but before we started Udacity, like almost 8 years ago or something.
Dang.
And I started basically making the videos to send to other people, to teammates at Udacity for like this is what we want to do in the course, etc. And then they
Uh-huh.
just kind of became YouTube videos, so the channel started getting views. But I also, yeah, so our goal at Udacity was always to teach it to everybody, and so I
Yeah.
was trying to make it as wide as possible, so like beginners would understand the stuff, but an advanced one would still be like, oh, I see what you did there, all right, like a
Yeah.
different spin. So try to be as wide as possible, and yeah, I also started with some. I think I had the only. I don't have a lot of running jokes, but I had one with mountains at the beginning because I said gradient descent is like descending from a mountain, and so I call it Mount Everest. And I felt like a
Oh.
genius and then I realized that it's very easy to put error names in mountains because then you can sue Mount Kilimanjaro. And then I went to give a talk in Seattle, Washington, and I said Mount Rainier. And then it just became a challenge to make any name into a mountain. So I gave the talk in Spanish and I call it Mount A Concagua. That's a stretch. But the biggest stretch was in Iceland because the volcano that stopped all the flights in 2012. It was called. I may butcher this, but it was called the Eyjaf Eyjafjallajökull, something like
Uh-huh.
that. Hope there's some Icelandic people that will correct me. But Eyjafjallajökull was the big volcano in Iceland, and I looking at Google Translate, I found out that the word for error in Icelandic it sounds like vidla.
Oh.
Again, I may be wrong, but and then I just call it the Eyjafjallajökull, and so I had that, and that's when I ended with mountains because you can't top that, right? Like.
That's as good as it gets.
So that's the only running gag I have. I may get to more later, but that's the one. Yeah.
I
What
love that
about you,
one.
Jay? You got a good
Well, so
style
I
there.
started out in blogging actually, and a lot of my
Okay.
initial
Mm-hmm.
sort of content was written, but it was highly visual as well. So the main artifact of it is the many visuals. And my first videos I created when I joined Udacity with, so a lot of it is just taking on what the team was doing there. So in terms of scripting it, explaining a specific concept, but definitely all of my influence is the two of you and your videos. Like I've logged hundreds of hours sort of watching both StatQuest and Luis's channel, and in addition to you two, I think maybe 3 brown, 1 blue, or I always get these mixed up. So those are the things that just made the way for me to understand data science a lot more accessible, because new concepts are a lot of the times intimidating. But then when you have people who present it in this sort of style that's playful, that's gentle, that's there's I feel very grateful to the people who sort of do that and sort of feel the need to push it forward. So with Udacity, I think we created maybe 10, 15 videos. And I think I've had also a lunch with Luis where it was the first time where I was scripting something with somebody else, sort of not just working in my own on a silo. And that one lunch definitely sort of highly elevated my video game. And it's when I transitioned to Apple Keynote, which I still use up until now, which was just dramatically improved my visuals game and animations. And so it translated to both video and improved a lot of the written things that I did. Now, video evolves, and a lot of it has been a learning curve. So YouTube was the big thing 5-6 years ago. It still is very big for education, but then I also sort of think about and explore other social media. So I found LinkedIn to be sort of interesting. But then how would a video be different if it's going to be posted in LinkedIn versus YouTube, for example? And then you have all the vertical videos and the short videos with TikTok, Instagram Reels, YouTube Shorts. That's another complete format that sort of needs to be figured out a little bit, and it's quite different. So it's a bit of figuring out how the platform sort of evolve with time.
Gee, I need to talk to you about all of those alternatives to YouTube as soon as this is over. I'm like, what am I supposed to do?
No, I definitely think of them as just ways of repackaging. Really.
Yeah.
Like the hard thing is just creating the initial video and then
Yeah.
clipping it, changing the formatting a little bit, and just reuse of great content you've already created.
Yeah. Yeah. Well, excellent.
So we all use Keynote, right?
Do we all use Keynote? I think
believe we all
we're all
use
Keynote guys. Yeah.
Yes.
I've actually learned Keynote from Jay. I watched, he's got a video on like how he does cool things in Keynote.
Wow.
And so I watched that and I'm like,
That's
oh,
awesome.
I can do cool things too.
So we're all grandfathered in Luis then.
And I taught you Keynote. Wow. That's definitely my greatest contribution in AI then to
That's right. We should draw a
create
tree
Keynote
of
and then I'm Keynote grandpa. Yeah.
Exactly. Yeah, you should get like, I don't know, Apple should sponsor you or something like that.
They should. Yeah. If you're listening, Apple.
Exactly.
All right. So let me say one to the crowd. We have a few career questions. Feel free to throw them in. We're gonna have a special time for career questions around the halftime. So about what would be the 30 minute mark. But feel free to throw them in. I see a few new questions. Let's do some questions before we get into the meat of the LLMs. Karchik is asking about can we use machine learning to predict time series textual data? Anything you want to add there?
Yeah. So I'd say, I don't know, maybe. I actually have very, very, very little experience with time series. But I have heard rumors in the hallways that one effective use of XGBoost is for time series. A lot of people use it for time series. So if that's something that could be applied to your problem, that's something to look into. I don't think that's a great answer to this question, but I did want to throw that out there just in case.
That's good. XGBoost, I didn't know. Yeah, I would say throw in probably recurrent neural networks. Those are just the time series thing. Hidden Markov models, if they're still used, I know they're good. Convolutional neural networks of one dimension. Those are good for time series. And I've heard a lot about ARIMA recently. It's kind of combines a lot of things, and it's one that's, for example, I see it's native to a lot of tools that use it in the background. So yeah, but anything on LLMs, Jay? Anything?
Yeah, ARIMA and SARIMA and a lot of, let's say, the pre-transformer models. There are some transformer time series applications, but they tend to be, if you're not just predicting one time series, if you have a lot of them, that's where transformers tend to sort of outperform other methods. That's when I last checked, like a year or two ago. But time series textual data, like text generation, can be thought of as that way. And GPT models can be thought of as predicting over 1,000 which would, let's say, if your model has 1,000 dimensions in the vector, that's one way of thinking about time series for textual data. But I think mostly we're addressing time series just in general.
So I have a
Genetics, right, Josh?
excuse me.
Oh, go ahead.
Oh, I was gonna just posit an idea, which is, if it can be solved with a recurrent neural network, then it probably can be done with a transformer better. Is that, what do you guys think of that statement?
Yeah, a lot of approaches are what you get with RNNs that transformers are just gaining on it is context size. So transformers were sort of, for the first few years, were limited to in their context sizes, but that seems to be going away, and we have these very, very long context models that sort of seem to be gaining on that context limitation.
What about SSMs? Because they seem to be the transformer version of a RNN, right? Because I would say the transformer is the transformer version of a neural network, and in my head, the SSM is like the recurrent transformer, right? Do you think those will get the best of both worlds, like the best of RNNs and the best of transformers?
They are showing promise. We'll see how the adoption and how the scaling sort of continues, but it's definitely an active area of research, and a lot of people are sort of betting on it. But it's not yet gaining, at least in the text generation, it's not gaining on transformers yet. But it's important to keep on the radar.
And just because my brain is about the size of a small green pea, SSM is state space model. Is that right?
Exactly.
Okay, I got it. I'm so proud of myself.
That's pretty good. There's some of those acronyms that I always get wrong. I can never get DPO right.
What's that?
Like, I don't know. I think it's direct preference. It's either direct preference optimization or deterministic policy optimization, or the combination. There's 4 possibilities. So yeah, I mean, they get, there's too many acronyms. So
yeah.
So in the chat, I can paste
yes,
a visual guide to Mamba and state space models. This is an incredibly well-written article by my co-author of the book we're working on, Martin Grotendorst.
Yes, I love it.
Pasting it in the chat. It's an incredible illustrated guide to how these models
That's awesome. Yeah, put that in the chat. By the way, you just mentioned your book, which I love. I can't. When is it coming out? It's the best book ever.
Thank you so much. Really appreciate it. So we've been working on it for close to a little bit more than a year now. I think September is when it's going to be in print. So
That's soon. That's a month and a half away.
Yeah, we're wrapping up.
I cannot wait. I can't wait.
And the title of the book is?
It's hands-on large language models. It's going to be published by O'Reilly. It's going to be in about 400 pages, and it has maybe about 300 original images that explain transformers, their various applications, how to fine-tune them, how to understand how they work under the hood, but just a lot of focus on applications.
Yeah, it's absolutely killer. I just finished reading it a week ago, and I absolutely loved every single page. It was. Sometimes when you get review books, you don't read the whole thing. I read the whole thing this time. I was like, oh my gosh. I felt like I was like, if I don't read this, I'm going to be left behind. I was like, I was compelled. Holy smokes. It's so great. I cannot wait for it to come out. Jay, when it comes out, we have to have like a whole episode just about your book. Just maybe going through some examples or something. I absolutely love this thing.
So. That's great to hear. I really truly appreciate the sentiment. Yeah. Absolutely, no, would love to come and speak about it.
Hooray!
Absolutely. Now, anybody who's read the Illustrated Transformer, which is the place to learn transformers, I mean, that's the book is basically like a lot of that clarity and that breadth.
And chapter 3 is a refresh of the Illustrated Transformer, which was 7 years ago.
Oh my gosh!
But then how have transformers changed since then? And so we update that of modern day transformers with a focus on text generation ones, because that's the offspring of the transformer that really took off.
Yeah. All right, Lewis, what's next?
Well, speaking of transformers, I mean, I feel like we have so many questions. Let me start with the one that says, as from Read One, can you effectively learn and excel in generative AI without starting with NLP? So let's start with the non-NLP questions, and then
Yeah.
what are other things we can do in generative AI that are aside from NLP? I feel like images could be something good, right?
Well, I mean, you can think about the various modalities,
Generating.
right? Generating video, generating images, generating audio, and understanding those as well. So
Yeah, understanding.
I find the term generative AI a little unfortunate because it just has people think about the generation side, but the representation is just as important. And the things a lot of this rapid growth in AI is because we have better representations for all of these. And so, yeah, you can pick a modality and go with it. I play around with a lot of these products for video, but they tend to be possibly a little bit more complex. But if you have more experience with computer vision, for example, so yeah, doing things like Stable Diffusion or diffusion models is a good place to start, I would say.
Yeah, yeah, definitely understanding is something very important too, right? Like I learned from Jeff, I've seen two things: the representation and the understanding. I see it as like a human, right? You can't talk well if you don't understand a lot of stuff, right?
Yeah.
So you need the part of the understanding, which is pretty much what was there before generation, right? Like classification, all that stuff, clustering, like embeddings, pretty much is a good way to understand text and then be able to talk
True.
more.
True.
Yeah.
Because
Yeah.
a lot of these models are encoders and then a decoder. And
Yeah.
Exactly.
you know, if you give a text generation model some text or a prompt or the image generation model, it needs to understand that prompt somehow. And so it uses a language model just to understand or represent that text. And then it passes it off to an image generation component that sort of turns that understanding or representation into an image.
Exactly.
I don't know if this is part of the question, but I'm going to just say this. I don't think, natural language processing, that as a field has gone back years and years and years, right? You don't have to go all the way back to the beginning and learn Chomsky normal form and all those linguistics and things like that. You can sort of dive in at the transformer in the deep end with transformers and sort of learn the basics of how they work and sort of just start from there. You don't have to in terms of if you're thinking about natural language processing as a field of study that has a long history and all these, it's got its own language and of its own in terms of terminology and whatnot. If that's something you're worried about, that's I don't necessarily think that is needed. You can kind of sort of dive into the deep end with transformers because they were, in my mind, it was sort of like a a paradigm shift with transformers, right? Before then, people were actively trying to sort of parse sentences and come up with hierarchical structures and how sentences were formed and verb versus nouns and all this stuff, and they could graph all this stuff, and that was really sort of the state of the art 8 years ago. And then transformers came on the scene. They're like, oh, we don't care about any of that stuff. We're just going to take tons of data and just sort of average over all of it. And that has worked exceedingly well. And it's made all the sort of the earlier work, although interesting and cool and probably still has some relevance and can be incorporated in cool ways. I'm not saying it's all garbage, but in terms of just if you want to dive into sort of modern AI and things like that, you don't need to have all that extra stuff. You can just start with transformers because that's when this era sort of began, was in 2017.
Definitely, you can start here. I find this interesting analogy. I would say that NLP models in the past learn languages the way we learn languages as an adult in classes, like with adjectives and nouns and structure. And then the transformers learn a language the way a baby learns a language, which is throw words, and then eventually structures start appearing in the background, but doesn't even know what there is. He just learns to talk well, and obviously you learn to talk better if you learn like a baby, right? So yeah, this goes into the next question, which is what's the suggested roadmap for learning Gen AI? And I agree with Josh completely that you don't need to go to the beginning. You can if you want, and it's sentiment analysis, fun things that are interesting. But definitely you can start with LLMs, and you can start with just prompting ChatGPT or prompting Cohere model, Claude, any of those, and seeing how they work. What about you, Jay? What are suggestions that you have for learning?
I mean, different
generally?
people will have different paths, and definitely work on what interests you and what it intersects possibly with your current job or where you want your job to go. So all of that knowledge sort of helps you and helps your career. Yeah, for me, understanding how the model works and then building with it, but also writing about it. Just document, learn in public, show the people out there what you learn. That will also help you sort of. That's one of the when we're talking about videos. Like I create videos mainly for me to understand things, and I write as well for that reason. So as long as you sort of keep learning, keep documenting, and learn in public and publish the things that you learn and the things that you build, you'll pick your own sort of path through it of what interests you and what sort of next things interest you. And there's not a shortage in what kinds of cool things you can build out there right now with the current state of the models and how many of them are available for you to sort of play around with and either fine tune or just use pre-trained models as they exist and just chain them or prompt them in different ways and or do prompt chains that make them do interesting things. So definitely experiment and learn in public and these are the two best things that I can advise.
And watch Josh's videos on Transformers and read the Illustrated Transformer and watch Jay's videos. Yeah.
Exactly.
Yeah, I want to segue to another thing that I know Jay's working on. Is a question by Kalyan. How does the LLM work as a GitHub copilot or Office pilot or some other copilot? What are things involved to work as a GitHub copilot? Is there a difference in training data and output summarization? Basically, you can segue this into tool usage, in particular writing code, but anything else you want to throw in?
Yeah, so I think this goes back to the point that both you, Josh and Luis mentioned just now, how NLP sort of transitioned from 10, 15 years ago being writing all of these, code that does parse trees and this is a verb and this is a noun to the model, the code being just 100 lines of code or 150 lines of code. But then with that, you have 100 billion tokens of training data or a trillion tokens of training data that is high quality. And so what becomes more and more important is that data. How clean is it? And then how it's shaped across the three stages of training. So how you can get a cutting edge LLM right now is three stages. And the first one is called base training, and that's where maybe 95 or 90% of the training and resources go there. That's when you do the next token prediction, predominantly the language modeling training on it. And that's where you need a lot of tokens, but you need them high quality. You don't want to have, let's say, spelling mistakes or grammatical mistakes, because that's how the most of the model sort of knowledge is available. And that's, for example, a model like GPT-3 is just base trained. But then if you ask a base trained model a question, it might give you a question back. Or if it might be thinking that this is a list of questions, which is something that it's seen in its training product. Once people started interacting with base models, they wanted a different kind of behavior. They were like, okay, when I give you a request, I want you to obey that request. Don't give me like a list or what's a possible continuation. And so you have this second step of supervised fine-tuning or instruction tuning. So if I ask you a question, give me an answer. If I give you a request, fulfill it or obey it for me. And so you need a different sort of set of data for that. And you have annotators and data sets out there that do this kind of instruction tuning, which that data looks like, here's an instruction and here's how to obey it. Write me an article about mouse genetics, for example, and then the completion is the article and the contents, and one that is sort of high quality. Or summarize this long document, and then the completion is the summary. So that's the second step. And then the third one is the preference tuning. That's where you sort of get to align the model. It's called alignment, or sometimes it's called RLHF. Luis already mentioned DPO as one of these methods that do this without needing to do very complex reinforcement learning. And that needs a different structure of the data as well. That tends to be sort of in pairs. So this is a request to the model, and then these two this is a good, let's say, completion, and this is a worse completion. This translates into code in the same way. And so to do things in Copilot manners, you need the model to have seen a lot of code in the base training. And then the tasks that you need the model to do need some data in the supervised fine tuning. So if you use Copilot or Replit, for example, or any of these IDEs, you interact with them in a couple of ways. So one is they can do autocomplete, so autocomplete or generation for code. You write, for example, the definition of a function, and then you want them to complete it. That's one way. Or sometimes you want to ask them a question about the repo and they answer it. And so the more of that type of data that you include in the supervised fine-tuning phase, the better that model is going to be able to sort of do those use cases. That's a little bit of an entryway to how these models are built.
Great, thank you. It's a good overview. And in industry, what other like tool cases do you think are going to be big over the next few years? That segues into another question.
So I think even if the developments in modeling stop today, we still have a good 5 years of just engineering and product and business model innovation for what the models are capable of doing today. For a lot of cases, you still now need to go to the model to do the work and then come back. We definitely need these models to come to our workflows. So when I'm scripting in Keynote, I need Keynote to sort of be able to generate all the audio or the video. When I'm writing an email in Gmail, I need the model to be there for the common use cases that I need. So we need a lot more of either the existing tools to incorporate these use cases, or for a new class of tools completely that are built with Gen AI in mind as native. Like we don't have the right interfaces to do a lot of these things, and I think there's a lot of opportunity in innovating on human-computer interaction, with generative AI being, let's say, a native part of designing that experience. We have a long way to go in terms of building these user experiences.
Wow. Yeah, a lot of cool stuff. Thanks. I think we're at the half mark, and we promised we're going to talk about careers, and we have a bunch of questions about careers. So let's go into that a bit, and we can go back to LLMs after this. I see a lot of other questions in the chat about LLMs, but Kumar has a few questions talking about how to get into Gen AI, how to get into the industry after taking some online courses, etc., etc. There's also a few questions, one by Ahmed, about a learning map for graduate students to start researching in NLP. So I think we can sort of take this as a general question and be like, what are your sort of general recommendations for somebody to get into this field? And I'd like this because we probably all have 3 different paths.
That's true. Yeah. I'm going to start because I just can't stop talking about it. But my new career recommendation is, as soon as Jay's book is available, buy it and read it. Because literally, it's rare that I read something and I'm like, oh, I got to try this. Oh, I got to try this. It's like everything I read about that thing was all these kind of like cool use cases of LLMs beyond just like, can you write a poem for my, girlfriend's birthday because I don't have time to do it? That kind of thing. It goes beyond all that stuff. And it's like this is one example where he does, he takes all these documents and he clusters them, and then he annotates them, and he gives summaries, and he gives labels for all the different clusters. And it's just like the coolest thing ever. Because when I was back in genetics, that was like a real problem we had, which was there's so much, so many researchers are doing so much stuff and publishing all the time. How do you keep up with it? How do you categorize it? And it's kind of a nightmare. And I was like, oh, if only I could have done this back then, that would have been super cool. So I remember just reading these things, and the way that obviously the way the book is written is it's you're not supposed to be an expert. You're not supposed to know how to do all this. I mean, basic coding, but not like crazy complicated coding, because for the most part, all we're doing is, and I know Jay could speak about this more than me, but I'm just so excited about it. But a lot of it is just making configurations for the LLMs, and not necessarily like it's not like creating big arrays and having to like do abstract things and have pointers to weird parts of the memory. All that stuff's in the background. All you do is basically make configurations and then let it go. And so it's simple, easy, but powerful. And I just feel like when I was reading this thing, I was like, people need to know how to do this. Otherwise, because this is where the jobs are going to be. People that have this skill set. So I'm just going to toot Jay's horn all morning long, basically. I love this
I
book.
definitely
Yeah.
deserve. This is an amazing book.
Very much
So yeah,
appreciated.
first I second that. The first way to go to LLMs is read Jay's book.
Yeah.
Very much appreciated. And so it's informed by going around and speaking with developers and seeing what applications people are using these for. And so like after you think of language models as building blocks, you can then use them to build pipelines. As long as you know the individual capabilities that they're able to do, text generation, understanding, topic modeling is the use case that Josh you were speaking about, and it's definitely one of the most fascinating ones. And my co-author in the book, Martin, is the maintainer and creator of BERT Topic that does this with transformers, and I think he does an excellent job of sort of explaining them and let's say showing the power for this and how it's needed. Let's say when you encounter a million tweets, this is an incredible way of instantly being able to sort of make sense of them. And if I had a long time just to experiment with and do nothing, I would do a lot of just topic modeling on my own. I find that fascinating as well.
Yeah. It's such a cool
Yeah,
trick.
I find that good embeddings can do so much, right? Because a lot of algorithms that 10 years ago were like super clever, like a lot of sentiment analysis, like a lot of topic modeling, LDA, for example, were brilliant and they work. But now with like a really good embedding, you can do the most basic things, and classification becomes super easy, clustering becomes super easy, topic modeling becomes super easy. So it's like if the computer understands really well what's happening,
Yeah.
then that can go pretty far. So I feel like it's fun to redo all the stuff from 10 years ago with a good embedding. It just becomes easy, you know?
That's true. That's true. If
Yeah.
you've done it with TF-IDF or these sparse vectors, that you can go
Yeah.
back now with dense vectors that are tuned for this use case.
Yeah, yeah. I want to talk about learning a little bit, and I'd love to hear your opinions on how to learn something, because I see a few questions, about like how to learn. Um, and it's funny because I'm doing right now. I'm taking a break right now. I'm in a small sabbatical. While doing more YouTube videos and stuff. But one of the things I'm doing is I'm trying to learn to play the piano
Oh.
from zero, and I'm realizing I'm using all the stuff that I tell people how to learn and seeing if it works, because I give preaching about how to learn stuff, and then I'm like, what if I'm wrong? I learned a lot of stuff a long time ago, And so I'm doing the following, like I'm taking half of the time of like some theory, right? I'm like, these are the keys of something, and another half of the time of like just trying to play a random song. I have no idea what I'm doing in the background, but I'm just doing it, right? And I feel like that would work for AI. For a car, it would work too, right? Like you can do a bit of like reading on what the parts do and stuff, and then just go driving with kind of blindly. And that's what I recommend for machine learning. I feel like you can, go to any of the material that we have or courses and stuff like that, learn how things work, but then also just take a lab and don't worry about if you're understanding anything. Just run it blindly and then change something on it and run it again and then try to change the data or some random parameter and play with it, and then just do the two ends, right? And try to meet the two ends. Eventually when they meet, then you really know something. But if you learn a lot of stuff on the theoretical side, and then on the practical side, you get farther and farther, and just whatever's fun. I find big data sets that are fun. Things, sports, like things like that. That's sort of the best way that I've chosen to learn. I'm curious the two of you, how do you learn something?
Yeah, 100%. Like sports, there's a lot of video game data sets out there. Sort of whatever interests you, just use these models to explore and then sort of write about them. Once you get more comfortable with a specific use case, you can contribute to open source projects and be part of them. There are a lot of online groups, Discord servers, where a lot of people are coming together to learn together, to share their projects. And if you want to do research, there's also a lot of these open science groups. So Cohere for AI is one that you can sort of join and learn with people from around the world and contribute to actually creating language models and creating, say, cutting edge AI research. Hugging Face has a bunch of these Big Code and a couple of other sort of projects. So just collaborate with people online. This is an incredible. One of the things that I really loved about this field is how open a lot of the things are. You can go out and read the papers and download the code and play around with it. It's not protected, although it's getting a little bit more and more closed with the big labs a little bit now that its commercial potential is sort of very clear. But there's still so many opportunities for open science, open source, that you just throw yourself out there, label some data, take on some task, and then with that improve and create value and sort of elevate your knowledge in the field by working with people who are other experts or others who are also learning from the process.
Yeah. One last thing to add to that is try lots of different sources. Everyone has a different way of learning, and different people have different ways of explaining. And so it's good to just try different sources to see what fits your learning style the best. So just shop around. Don't just because one source is confusing and you didn't understand it doesn't mean that all of them are. When I'm learning something, I found that I look at everything I can. And even when none of it makes any sense, if I read enough of it, I start getting something from it. At least I start seeing terminology that's used consistently across all the different sources. And then I can maybe dive into those terms and eventually stuff starts making sense to me. So that's what I would recommend. So just try it. If one thing doesn't work, look somewhere else and keep going. Don't get slowed down because one, if you had one piano teacher that was not so awesome, you could get a different piano teacher who might be better or, maybe not. But you know what I'm saying? It's you wouldn't just stick with whatever's not working. You would look around and try to find something better.
Yeah, absolutely. I think if, I don't know why, I feel like from older generations, we have the tendency of push through, but sometimes pushing through is not. You can find a way around and find something to get to the same place or to a similar place that is more fun and more and easier, right? So yeah, I agree with that. There's some questions about career. So I feel like I want to talk a little bit about entry jobs. One thing that I suggest is if people are learning AI already, that means you're a data scientist. You don't have to wait until a certain point to start applying for jobs. I feel like you should apply for internships pretty quickly, and then you start getting interviews. And the best way to practice for interviews is interviewing, right? You go to an interview, let's say it doesn't work out, but now you know what questions you get asked, so you go practice on those. Kaggle is pretty good for doing sort of real-time data sets. When I interview people, I ask a lot of times about a project they did, and they give me a Kaggle project, and it's just like if they gave me a project in their job. So internships are pretty important. Big companies have AI internships, small companies as well. All of them. Cohere, for example, has a lot of great internships. I would say if anybody is taking courses, you should already be applying for these and giving it a try. Anybody wants? By the way, I just realized I'm looking at the live and I'm super pixelated. I wonder if my internet is super slow. But if you look at it, I look like a 1980s video game. But anything you want to add on careers, jobs, applying?
I was going to say, do it, get GitHub repositories with projects that are well annotated, well documented. Yeah. Anything like what Jay was saying, learn in public. This is a great way to sort of That's building your resume, and so I'd highly recommend that.
So I tell people to learn in public because if you look all around the world, the jobs that get advertised are only about 30%. 70% of jobs are filled before they get advertised. And that's what you would do if you're hiring for it. You'd ask your network, who is the best person we know? Who's the best person in our network that does X or Y? And if you excel at communicating the things that you learn, you brand yourself as an expert in this one point using the code that you've shared and the articles and the content that you create, you want to be a part of that 70% of sort of, okay, we know that X sort of knows this stuff. They've been writing about it. They've been thinking about this problem for a long time. And so that's, I think, one thing. But it also helps you, if you know that you're learning a thing and sort of publishing about it, that helps you also learn it deeper because you don't want to put something out there that is, and I've definitely put out a lot of things that the illustrated transformer, for example, I wrote a first version of that and I sent it to the authors of the paper. And they gave me a lot of incredible feedback and corrections and things that sort of I didn't understand very well in the beginning. And that dramatically improved the post. And then sort of I thank them on there. And so if you can undertake explaining papers as a thing, and whenever you send that for review for the authors, they will be very grateful for you trying to sort of explain and spread their work. And this will give you more and more. It's a great life hack I've seen. So the more you make let's say a reputation for yourself on specific topics, the more doors will be open to you, and you will be sort of in less competition with others because you have that area sort of branded well for yourself.
Yeah, good connections, good network. Also go to events, make friends, talk to people. I think I've got most of my jobs as referrals, you know, like Jacob, Minko here, and places like that. So yeah, I think having good people to talk to and improve your network is very good.
Yeah.
Yeah. I want to get back to LLMs. I see questions about LLMs, but there's a few general AI questions that I want to touch on. There's one on graph neural networks, which is something I've been interested in learning for a while.
Me too.
What
So
do
I
you
was
guys
hoping you
think of
guys
that?
could talk about that.
Do you know, does anybody know? Yeah, I've been wanting to make a video about that, and I think it's very interesting because there's a lot of data that is graph-like, right? Because like, you know, every neural network picks up on something, right? Like neural networks pick up on data that if you move the rows or the columns, nothing happens. CNNs pick up on data where things are correlated to their neighbors, like an image, right? And RNNs pick up on sequential data. And I feel like graph neural networks sort of pick up on data that is organized as a graph. That's pretty much as far as I go, but this is one of my topics to learn next. So yeah.
Jake, can you help us out?
Well, I haven't looked very closely at them. I know there's a lot of interesting work, and a lot of data sort of lends itself nicely to graph structures. There's also graph databases that are also sort of relevant for this, but no, it's a field where there's so much going on. I haven't sort of gotten to dive too deep into that.
Yeah. What's next, Lois?
Well, there is a question about linear regression. I've said a question about linear regression. We're estimating coefficients with standard deviations. Is not sufficient to say coefficient is non-zero. I feel like, let's see. I don't fully understand it, Harsh. Do you want to elaborate?
Yeah, I was gonna say that doesn't make sense to me.
But you know something interesting, and it is that when you look at, I look at linear regression now not as like you're trying to find the, like I don't have the picture of the line and the points anymore. I feel like at every line you can draw a little Gaussian, right?
Yeah, exactly.
And I feel like you may have something like that in your videos, Josh, right? Like you have a little, like a distribution at every point where like the thickest is at the line and the thinnest is on the sides, and you're pretty much trying to find how likely is it that the points are generated with that line, right? Like if you're close to the line, you're generated, you're likely to get generated there, but if you're far, you're unlikely. So you multiply them, and that's what you get, and from there you get the loss function, right? Something like that. I don't know. Yeah. Anyway, so Harsh, if you want to elaborate on linear regression, go for it.
Yeah.
I want to ask you a question about RAG. So Ali says, what are the best combinations of RAG methods would you use to have the best RAG products or re-ranking, hybrid search, etc.? I know Jay and I made a course on that. So if you wanna
I
talk
was going to say,
about
I just
what's
read a
the
chapter in Jay's book on that.
so what's the best combination for how to do a RAG pipeline?
So, and this also goes to another question here that says fine tuning or RAG. And, RAG is this idea of retrieval augmented generation. When LLMs first came out, people asked them questions and they answered some of the questions correctly. But people started using them or thinking of them as search engines, which is not sort of what specifically language models are trained to do. But the better way of doing it is this two-step process of search first and then generate the answer. Provide the model, instead of giving the model a question only, give it a question and give it some context that hopefully contains the answer, and that will improve its ability to answer that question. And so that is the most basic formulation of retrieval augmented generation. But then that's a simple primitive RAG system, and you can improve on that in several ways. Re-rankers are one way to improve that search component in the beginning. You can add embedding search or hybrid search is even better when it has, let's say, keyword search and embedding as a first step search, and then you re-rank the, let's say, top 10 or 100 results, and that also tends to improve the results that you'd get. But then there are advanced RAG methods as well, and these include things like query rewriting. So if you get a very long question, you don't necessarily search for all of that entire paragraph or question. You're like, okay, what are the keywords that I need to answer for this? And then sometimes you have a question like, compare for me the financial results of NVIDIA in 2020 and 2023. Do you find one document that contains both these pieces of information, or do you need to do two queries, one for NVIDIA results 2020 and 2023? And you're talking about an idea called multi-query RAG, where the model is able to sort of search for multiple things. And then there's another class of questions where you can't answer it in one step. You need to first search for something and then make another search after it. So if I say, what are the top car manufacturers right now, and do they make EVs or not? So in the first, you say, okay, what are the top car manufacturers? And then it will tell you, okay, it's Toyota, Volkswagen, and let's say, I don't know, Mercedes or something. And then you need to go and search, okay, does Toyota make an EV? Does Volkswagen make an EV? And so that's another list. And this is what's called multi-hop RAG, where you have multiple steps. And slowly you're sort of evolving where the LLM wears multiple hats in order to answer questions correctly. So deciding what does it need to search or not, what queries does it need to search, and once it searches, does it have the final answer, or does it need to make more searches? And then in the end, this idea of grounded generation, which is given the context, answering based on the information in the context. And pretty soon you're becoming the LLM is becoming more than just a text generator. It's doing a lot of the reasoning. And you're building into it this capability that makes it more and more like what's now being called agents. And so where it really acts on the world and uses search engines, and then this evolves into other tools that it can bring information from, but also maybe post information or do actions on the world. And this is the new shape of LLMs and the new type of software system and the promise and potential there is it's absolutely clear that it's going to change so many things in technology, but it's way too early, but we're seeing the potential clearly.
I have a follow-up.
Yeah.
Let's say that you're doing RAG, and your documents are a page of one for every car, and I want to know what's the most expensive car. Is that? But I don't have a page that tells me all the prices. I have to look literally at all the cars. Is that doable, or is that something that we're still working on?
It depends on the LLM. So not all LLMs will be able to sort of, and it depends on the retriever, the search sort of system. So if you're doing it in this multi-hop multi-query way, yeah, an LLM that's trained in that way is going to have a better chance of actually getting that information.
Because it literally has to retrieve all the pages and do some logic.
Yes.
Like check which car is more expensive, right?
Yes. And then this also factors into long context. So how much of these documents can it have in its context as it's doing the grounded generation? So it has, if it has a very long context and it can fit the top ones. But there are definitely a lot of things that are in this formulation. They're not, you can't answer all questions. And some of them, like structured information like this, like comparing dates across a lot of documents, will it see all of the information that it needs or not? You might need to build a specific system for a question like that.
Interesting. Yeah. Because RAG can go really far, but there's a few like sort of conceptual things that are still hard for, right?
Yeah.
Yeah. Ali's asking a question that is more like a rapid fire. LLMs, sorry, fine tuning or RAG?
Yeah.
Sorry, Swain is asking this question. Fine tuning or RAG?
We touched on that a little bit, and it's that if you need to ground your LLM to answer from to answer either factual information or information from a specific data set, RAG is the way to go. Fine tuning is really not the way to inject new information that the model does not know. And fine tuning is maybe a good, last ditch effort for either adapting an LLM to a specific domain or to have it output things in a specific format. But generally, try to solve things with prompt engineering. If you can't, try to do RAG, and then fine tuning comes at the very end.
Okay, I like to think of fine tuning as like studying, taking a master's, like learning more stuff about something, and RAG is like carrying a book around and answering from the book, or like or your phone or Google, right?
Yeah. Yeah,
Is that a good? Is that the right way to think of it?
I
or
like
is
that.
it-
Oh, Lewis, you always have the best analogies.
I know.
I love it. I just
So
love
that's how I explain stuff to myself. If not, I don't understand.
I love
But
it.
So,
even better yet, is even better than a book. It's like you have your phone and you can look up
Your phone.
Wikipedia and look
You
up
just
more
look in
recent
Google.
information, because
Yeah.
you don't want to
Okay.
fine tune every time the data changes.
Yeah.
With RAG, if the
Exactly.
data changes today, the model instantly sort of has access to the latest form of the data.
Yeah. It's cool.
Yeah, I think a combination of both, right? Like probably one is better takes longer to train and faster to serve, and the other one is no training but serves takes some time, right?
Yeah.
So, but I always recommend to do both.
Yeah.
Right? Plus good prompting, like a
Yep.
good preamble. I think that's pretty much the most you can get of an LLM at this point, and would you trust that it's pretty accurate? Like, would you trust that an LLM that has fine tuning and RAG, would you trust it on like a health decision or like something like that?
You should not.
You should
not
not.
for high
Okay,
stakes
this is good to
decisions.
know. This is good to know.
You always need to have a human in the loop, especially for high stakes decisions. If
Yeah.
it's something
Okay.
that's like
Yeah.
you're gonna hire people over, or if it's like medical, the model of the system can inform or help an expert, but high stakes decisions should be made by humans.
So, on that note, time flies when you're having fun. I can't believe it, but it's been an hour.
Wow.
So we have to wrap this up. I've got a meeting I have to go to. I need to stop scheduling things after this, and we could just go all afternoon. But we have to wrap it up. This has been super fun. Jay, thank you for joining us today. We hope to have you back. Lewis, is always great to having you. Holy smokes. Again, Jay has a new book coming out in September. It's being published by O'Reilly. It's being called, what's the name of your book?
On large language models.
Large language
Put the
models.
link in the live, in the chat.
Yeah.
Hands-on large language models.
Yeah. Anyways, it's amazing. Check it out. It's a month and a half away from being published, or maybe 2 months approximately. So get it as soon as you can. But anyways, it's great having you guys. I hate to wrap this up and run away, but the time has come. We've gone for an hour, and so thank you again. And alrighty, with that, I'll see you next time.
Thank you so much. I learned so much talking to you today. Thank you, Josh, as usual. I love talking to you. Thank you, Jay, so much for all the stuff you talked about. Really cool. I was love
Thank
talking
you
to
for.
I had a blast.
Right.
Yeah, I'm delightful
so much.
speaking with two literally of my heroes that I learned so much about. So thank you so much. Looking forward to the next one.
Hooray.
Thank you. Yay.
All right, I just ended the stream.